So, we have discussed the algebraic structures and number of algebraic systems mainly based on some properties we have read, and almost all the algebraic systems like group, the semi group, monoid, or the last algebraic systems that we have read is the ring. There everywhere we considered one example where some modular operation we have discussed or we considered. Now, we have defined there in very short that what do we mean by the modulo n, a modulo n or a modulo b. Now, today we will see or we will read in details the modular arithmetic, because this has a very important role in algebraic systems or particularly this modern algebra. So, today we will mainly consider the modular arithmetic, its definition, the different properties and some application areas. So, first we define that what do we mean by modulo. So, let A be an integer and n be a positive integer. Then if we divide A by n, then we will get a quotient or integer quotient, say q, and a remainder r. Where 0 less than equal to r less than n and q and r integer. So, we can write that A equal to q n plus r, or q that r remainder is greater than 0, greater than equal to 0 or less than n. If it is divisible by n, A is divisible by n, that means there is no remainder, that means it is 0 or it is less than n. And q, I can tell that q is floor A by n. Floor A by n, earlier we have defined that it is the largest integer less than or equal to A by n. So, I can write that this is floor A by n into n plus r. Now, this r is sometimes called the or the remainder R is called the residue or that it is the remainder when A is divided by n, it is called that A modulo n or A mod n. So, mainly the remainder when A is divided by n, that it is called that A modulo n. So, we define that A mod n, we define A mod n to be the remainder when A is divided, A is a integer, A is divided by the positive integer n. Positive integer n. Example we can give. So, this is my definition of A modulo n. Okay. If I give an example, simple example, if we see that say 11 modulo 7, that means when 11 is divided by 7 and we know it is nothing but 4. So, what will be minus 11 mod 7? Minus 11 mod 7, this can be minus 3 can be the quotient, minus 1 be the quotient and then 4 is. So, I can write this thing as minus 1 into 7 plus minus 4, this is minus 11, or same thing I can write that 2 into 7 minus 2 into 7 plus 3. So, this can be, since the way we have defined it is the remainder. So, this can be the remainder minus 4 or this can be the remainder. So, minus 11 mod 7, I can write this is 3 or even sometimes we can write minus 11 mod 7 is minus 4, but normally the convention is that we give the as a positive integer, because the remainder we have defined that, if we remember that we have defined that my r is 0 less than equal to r less than n and n is a positive integer, n is a positive integer. So, since r greater than 0 equal to 0, so this is positive and less than n. So, here say this n is 7, in this case n is 7. So, my A modulo n is 3. So, this is my definition of my modulo. Now, all of we know, but again I repeat that sometimes we call that divisors. So, normally divisor is when there will be no remainder. So, divisors that if say n divides a, we normally we write in this way, n divides a. That means, when a is divided by n, a positive integer, then there is no remainder. We tell or we mention that a is divisible by n. Or I can tell that n divides a, and normally the notation is n divides a. So, the divisors have some property, though it is very primitive, but we require for this explanation of the different property of a modulo n. So, we quickly write those things, the some of the properties of divisors. We can write that 1, if a divides 1, if a divides 1, then a equal to plus minus 1. If a divides b and b divides a, then a equal to b. If any b not equal to 0 divides 0, b divides 0, then b divides 0, we call b divides 0. And if b divides g and b divides h, then b divides mg plus nh, where m and n are positive integer, or m and n are integers. So, we can explain that fourth property, because the properties 1, 2 and 3 are very trivial, all of we know that thing. So, we just explain the property 4. It tells that b divides g and b divides h, then b divides mg plus nh. Okay. So, if b divides g, that means we can write that g equal to, then G equal to some B into some G 1, because it divides, that means there is no remainder, only quotient. So, if I multiply both sides by G m, then m G is B into m G 1. Similarly, if B divides H, then H equal to B into H 1 and NH equal to B into NH 1. So, now if I add these 1 and 2, so adding 1 and 2, we get mg plus nh equal to b mg 1 plus nh 1. So, mg 1 plus nh 1, this is one integer. So, we can write that. So, some, if I write, or this equal to b into some, say k, one integer. So, k equal to mg 1 plus nh 1 is one integer. So, b divides, can write that b divides mg plus nh. So, the property 4, it is proved. We can explain in this way. Now, we go to some properties of modulo operator. Because just now we have seen some only or normal division, that some of the properties, when it is properly divisible, or if some remainder is there. If some remainder is there, then actually our modulo operation comes into picture. Now, if a modulo n, we have defined that a modulo n, we write a mod n. A mod n is the remainder when a is, when n divides a. Okay. Now, n divides a. Now, if n is a positive integer and a is divided by n, then the remainder can be 0 to n minus 1. So, when a is divided by n, the remainder can be 0 to n minus 1. These are my remainders. So, a modulo n is the set, I can write that this is 0, 1, 2, 3 up to n minus 1. Now, we will see some arithmetic that which works on this set only, or we will see the whether our ordinary addition, subtraction, division or multiplication, how it works or whether at all the similar way it works on this set, because the modular arithmetic, now I tell that A mod n is nothing but these it can be only the set of elements from 0 to n minus 1. So, first we see the modular arithmetic operations. So, first we consider the addition. Okay. We consider the addition. So, addition we can write that A modulo n plus B modulo n, if I take the or I can write in this way A mod n plus B mod n, and then I again modulo n, then I will be getting A plus B modulo n. First we see that, see here my A modulo n is a set any elements from 0 to n minus 1. So, this is a set from 0 to n minus 1 any elements. Now, similarly B modulo n, because it is divided by n. So, this will be again 0 to n minus 1. So, these are two numbers, and then again if I take modulo n. So, the whole thing that this thing again is becomes 0 to n minus 1. And similarly, if A plus B, whatever be the number large, whatever large number it is, when I am dividing it by n, and since A mod n is nothing but the remainder. So, again this thing is from 0 to n minus 1. So, that means this, then we know that this is A modulo n plus B modulo n. If I take the modulo n, then this will be the A plus B modulo n. So, how we can prove? We see the proof. So, let this is continued. Let A modulo n, that means when A is divided by n, is actually R A, and B modulo n, when B is divided by n, the remainder is R B. So, I can write A equal to some k 1 n plus R A. K 1 is the quotient when A is divided by n. Similarly, I can write B equal to k 2 n plus R B. So, here I can write that my k 1 is floor A by n and 0 less than equal to R A less than n. Similarly, here I can write k 2 is floor B by n and 0 less than equal to R B less than n. Now, if I add this equation 1 and equation 2, equation 1 and equation 2 if we add, then we will be getting that adding equation 1 and 2, we write that a plus b equal to k 1 n plus r a plus k 2 n plus r b. So, equal to I can write r a plus r b plus n k 1 plus k 2. Now, if I divide this equation, so I can write a plus b. Now, say this equation I give name equation 3. So, if I divide equation 3 by n. Okay. So, divide equation 3 by n, this will give, and if I take the remainder of that, so this will be a plus b modulo n is the remainder from left hand side, and from right hand side this will be my r a plus r b modulo n, because here n into k 1 plus k 2. So, this is when I am dividing by n. So, there will be no remainder for this part. So, for this part, since is n into, so divided by n will give 0 remainder, will give remainder 0. Now, a plus b mod n equal to r a plus r b mod n, that gives what is r a plus r b? Remember, see that r a is a mod n. So, this is nothing but r a plus r b is a mod n, r a is a modulo n. Okay, I can write here. So, a modulo n plus r b is b modulo n and this mod n. So, this is mod n. So, the property 1 or the addition property, is proved, that a plus b mod n equal to a plus a mod n plus b mod n mod n. Now, the totally similar way, I can prove the subtraction. So, the property of subtraction, that we can write that subtraction that a modulo n minus b modulo n, if I take a modulo n, this will be a minus b modulo n. And the way we have proved my addition property for modulo operator, the totally similar way we can take, only that when we have adding, that time we have to subtract equation 2 from equation 1 and the remaining things are same. So, if I write the multiplication property, that we have to read that a modulo n into b modulo n, we take again modulo n is A into B mod n. Now, the way we have proved, if the same thing we can do. So, multiplication proof we can now take that a similar way we take that A mod n equal to R A. So, let A mod n equal to R A. So, A equal to the way we have taken K 1 n plus R A, and B mod n equal to R B, we can take B equal to K 2 plus K 2 n plus R B. K 2 n plus R B. Now, what is my A B? Because when we have proved the addition property, we have taken the equation 1 and 2, we have taken the sum. Now, we have to multiply. So, if I multiply equation 1 and 2, we will be getting A into B equal to K 1 n plus R A into K 2 n plus R B, and we will be getting R A into R B plus that we can take K 1 K 2 n square plus K 1 n R B plus K 2 n R A. So, this will be R A into R B plus, if I take common n. So, I will be getting K 1 K 2 n plus K 1 R B plus K 2 R A. Now, see, similarly, if I divide A into B by n, so dividing by n and take the remainder, we get A into B modulo n is only R A into R B, because again here n is there. So, when I will be taking dividing by n, this part will give the 0 remainder. So, if this is, if we remainder that A cross B modulo n is R A is my, okay, this is R A R B modulo n, then this will be A mod n into B mod n into mod n. So, it is proved. But see, we cannot do this thing for division property. We have only multiplication, subtraction and the addition. Okay. Okay. So, just the basic properties that modulo operation holds, that we have read here, and some more properties when it is repeated multiplication or repeated addition, and that will be reading in the next lecture.